This is a cold energy circuit. We call it cold because we are not using the heat from the positive to run the circuit. Instead, we're using the cold from the negative. I point out temperature difference in this because this circuit will not heat up like a traditional circuit. It'll stay cold at all times. Let's look at the parts we're going to use for this. We're going to use an MJE13009. It's an NPN, and it goes from emitter with diode. We have our base, and we have our collector. Pretty easy. We're not changing any of that. As a matter of fact, the circuit's going to flow properly through that. This is backwards from a traditional circuit. Please understand that up front. We're going to pull in through the negative into the coil, pull the cold side into the coil. Then we're going to pull the cold side this way and pull it through the switch. Now, traditionally, this is fine. It goes in through the negative here to our signal generator, and the positive goes out here. Let's go back to the switch. As it comes down here, it's going to go here. Then it's going to go up here, right through the emitter. The diode's on the emitter side going in this direction, so it will go to here. It'll stop at this point. Now, we're going to look at the other side. This is our positive side. It comes in here. It'll go down through our cap bank and then over here and create a positive side. We see the cold side or the negative side. It also goes into the cap bank and pulls here. Now, we have our negative and our positive, but we've also produced a switch. Here's where we get a little excited with this circuit. The signal generator puts in a signal and will create the base to pulse this right here between emitter and collector. It'll create the pulse rate in order for the switch to turn. Now, that's pretty traditional. The hot side will also come back over here. We see it move over this, over that cold side, and right here. This is important. This is a neon bulb. It'll take the hot side here, the cold side here, and light up the bulb. Now, this is why it's important. It breaks the hot side in the bulb from the cold side that was used to turn this on. The hot side is like an attraction to the whole thing. It pulls the cold side through the whole system. That you need to keep in mind. Now, with all that said, we need to look at one more part. Right here, we know that the cold side comes through here. We know that it goes up here. We know that it mixes with the hot side. So what's going on here? If we turn this off, we simply have the cold side turning on the switch. What does that mean? It means that it will continue to pulse at the rate of the coil as long as there's energy in it. So this will go through here and continue to pulse this in this direction. If the signal generator is on, it will take over that and run this in this direction. It will be the primary pulse for the whole circuit. Remove the signal generator power, it still pulses the circuit. It's in negative configuration. If we double this circuit and add a secondary coil, now we can traditionally turn on a second coil and get them in resonance together, and as they resonate, this will come through and continue to resonate the entire circuit. This is a cold energy circuit. It is not a hot energy circuit. Why use an NPN then instead of a PNP? The reason to use an NPN is you notice there are no resistors in this circuit. A resistor means heat. Unwanted heat in this circuit is a very bad thing. It ruins the entire effect of a cold energy circuit. We do not want that. We want to keep The resistor's out. We do not want the unwanted heat. Again, you see this neon bulb right here. It removes unwanted heat from the circuit. That's the understanding of the cold energy circuit.